Hi there. In this video, we'll learn about the economies of scope and the cost complementarities. The concept of economies of scope is likely to be overlapped with economies of scale, but there is a substantial difference between the two because in economies of scale, the production is of the same good, but it happens at a larger scale where most of the inputs they increase. But here we are talking about scope, and scope relates to the types of the goods that are being produced. So let's see that how this thing can happen. You are encouraged to subscribe to this channel if you haven't before, and you may click the bell icon to get the updates of the latest material. So under economies of scope, the cost reduction takes place, and it takes place when we are able to produce two or more products together instead of producing them separately. So this is what economies of scope is, the benefits that are reaped if we are able to produce more than one goods together instead of making them separately. Mathematically speaking, it shows that the total cost of producing Q1 and Q2 combined is less than the total cost of producing Q1 separately and total cost of producing Q2 separately, where zeros show that here Q2 is not being produced and here Q1 is not being produced. So this is what economies of scope is in mathematical terms. Cost savings can also be found, and for that it is simply the percentage formula where we are mentioning the total cost of producing the goods separately minus the total cost of producing the goods combinedly divided by the total cost of producing the two goods separately. So it shows that how the additional cost is taking place once we are producing them separately instead of producing them in a combined way. So these are the two major formulas. We go ahead with a few points of discussion regarding this concept. Companies produce beef. When they produce beef, they can also produce leather because leather is the skin of the cattle from which we get beef. And when we have soft drink companies, they can also produce iced tea or energy drinks. This is another situation where they can benefit from the economies of scope. And these favorable economies of scope compared with the firms that have two separate plants. So instead of having two plants, there can be one plant where the production can take place in a combined way, and that will give us a favorable outcome in the form of economies of scope. We have butter and cream companies. They can go towards skimmed milk, and that is more lucrative because they can make more money out of it instead of producing the original products like butter and cream. Or they can produce all of these products because when they do this, there will be economies of scope. And what happens with the cost is that it declines because there is collective scope, and in that collective scope they can capitalize on their comparative advantages. They can gain more experience from the original products that can further help them to produce the newer products with ease and with less cost. They can utilize the same distribution and supply networks that are already being used because for the previously produced product, the distribution channels and the supply networks, they already exist. For the new products that are being produced to gain the economies of scope, we can easily use these already existing channels. This will again help to keep the cost low. And the same market base and consumer loyalty can be exploited that has already been exploited before for the sake of the new product. So marketing and finding the consumer will not be any serious issue when it comes to producing newer goods, similar goods to gain from the economies of the scope. Now all of it can be quantified with the help of this numerical example. You can see here that a company is estimated to have two options that it can produce goods jointly, and if it does, it costs this much, that is $7.5 million, and the other option is that it can produce separately those two goods, and in that case the separate cost would be this much. That is for the first good and for the second good. So now we can assess if there are economies of scope in this situation or not. Now let's talk about the extracted data. This is the extracted data. The joint production cost is this much, as we have already read it here, and there is separate production cost, and that is for the product 1, and then there is separate production cost for product 2, which is 3.8 million. So all of this information is already given. Primarily, we can start with the cost savings, and here we are, the formula that we just read before. It's the same formula. Here we are going to put the values. This is the total cost of producing the first good separately, for product 2 separately. This is the total cost of producing both of the goods jointly, and this is the sum of the production of first good cost and the second good cost separately. So the answer is 0.16, which if expressed in percentage terms is equal to 16.0%. So this is the interpretation that if we go towards the joint production, it is going to reduce the total cost by 16%, which is substantial, and it is likely that there is the presence of economies of scope, due to which the total cost by producing jointly has declined. In addition to the total cost, marginal cost has also relevance with the economies of scope, because we can use marginal cost in determining if there is economies of scope. We can check that, and for that we use the concept of cost complementarity, which means that there is complementation between the cost of the first good and the second good. Here we can see that if we produce an additional unit of second product, it will affect the marginal cost of the first product in a way where it decreases. So it means that if we are producing another additional unit of the first good, it is going to decline the marginal cost of the first good. So there is a favorable outcome that producing one good will decrease the marginal cost, and the marginal cost will be of the other good, which means that there is economies of scope as well as there is cost complementarity between Q2 and Q1. This is the same thing that we have just observed with the help of this symbolic expression. This can also be understood with the help of cross-partial second-order derivative, and it will be negative when it comes to the joint product cost. So you can see that we have taken the marginal cost here of the first good, and we have taken the derivative of it with respect to the second good. And if we do this, it will be less than 0. It means that there is a negative relationship between the production of the second good and the marginal cost of the first good. So there is cost complementarity, as we can see with the help of this expression. We can see that marginal cost of Q1 will decline when the output of this other good or the second good increases. We can also express this in terms of total cost, because we know that marginal cost is extracted from total cost. So when we take the second order derivative of total cost with respect to Q2 and Q1, then the answer will be negative. So in terms of total cost, we can write the same expression like this. Now for the product 2, the condition will be, here you can see the reversal. It was MC1 here, so now it is MC2, and it was Q2, and now it is Q1. So there is a reversal of the variables here. When Q1 increases, the marginal cost of the second good will decrease. So there is a negative sign. The relationship between Q1 and MC2 is negative. In terms of total cost, we can write it like this, that the total cost when taken the second derivative of it with respect to Q1 and Q2 will give us a negative answer. So as a result of it, we can write that the relationship in case of cost complementarity between the marginal cost of one product and the output of the other product is negative. We can resort to a numerical example to make more sense of it. This is the expression for total cost where two goods are being produced. We want to know if there is cost complementarity in it, and we are given the certain values of Q1 and Q2 where we want to know if there is economies of scope. So let us use this total cost function. For the sake of cost complementarity, we remember that we have to take the second order derivative of total cost. So we started with the first order derivative with respect to Q1 of the total cost. The answer was this, and then with respect to Q2, because it is second order partial cross derivative, and the second order derivative will be equal to -2, as we can do it very easy. You can pause the video and do this simple calculation. So it is negative, it means that there is cost complementarity. We can also do it with respect to the other good, that is Q2. So primarily we differentiate it with respect to Q2, and this is the answer. And then the total cost is being differentiated with respect to Q1. And the final answer is negative, which means that there is cost complementarity. Answer is the same because we have taken the cross partial derivative. Under the right of Young's theorem, both of these derivatives should be equal. So cost complementarity has been verified. Now we can assess the economies of scope, the presence of it. So economies of scope, for that, the condition is this, that is the total cost of producing Q1 and Q2 jointly should be less than the total cost of producing Q1 separately and total cost of producing Q2 separately. And now we can take their sums, and the sums are equal to this, the separate cost is there. Joint cost should be less than the sum of the separate cost. This is the condition of economy of scope. So now we can assess these three values, that is the total cost, the joint cost, and the separate cost. The total cost for Q1, total cost for Q2. The joint cost, the separate cost for Q1, and the separate cost for Q2. These are the values that we are already given. Q1 10 and Q2 15. These are the two values that we were given in the given information. So by putting these values, we have these three values that we were looking for. The answer of the joint cost is 525. You can pause the video and see these calculations that I have underlined. And total cost for Q1 is 600. The total cost for producing Q2 is 725. So the sum is 1325, which means that the total cost of joint production is less than the sum of the total cost of the production in case of separate production. So here we can see that the economies of scope exist here, and the joint cost is less than the individual costs. So this is how we can understand the concept of economies of scope. We can numerically solve it as well. We can also find the cost complementarity. In addition to that, we can also calculate the cost savings, which is a very important thing to know when it comes to managerial decision making. And this was the concept of economies of scope and its numerical application. I hope you have benefited from it. You may give it a thumbs up. Thank you.